Hello and welcome. Our topic for the day is simplifying radical expressions, including variables, requiring some factoring. Before we go on to do the questions, let's understand the steps involved to simplify radical expressions. The step 1 says find the prime factorization of the number inside the radical. Start by dividing the number by the first prime number, that is 2, and continue dividing by 2 until we get a remainder. Then divide by 3, 5, 7, etc. until the only numbers left are prime numbers inside the radical. The next step is to determine the index of the radical. The index tells you how many of the kind you need to put together to be able to move that number or variable from inside the radical to outside. For example, if 2 is the index, that is a square root, then we need 2 of a kind. If the index is 3, then we can have to combine 3 of them inside the radical to move down as 1. Now the next step is move each group of numbers or variables from inside the radical to outside. If there are not enough numbers that can be grouped, then we leave them as it is inside the radical. Our next step is to simplify the expression both outside and inside. We multiply all numbers and variables that are lying outside the radical as well as inside the radical, and we finally get our answer. To understand these steps, let's do some questions. The first question says simplify, and we're given 9 square root of 27 r 8. When no index is given, we assume that this is a square root. So we'll find out the factors of 27 as we had written in the step 1. Here it cannot be divided by 2, we start with 3. 27 divided by 3 is 9. 9 divided by 3 is 3, and 3 divided by 3 is 1. So this can be written as 9. 27 can be written as 3 times 3 times 3. R to the power of 8 can be written as R 8 times 1, 2, 3, 4, 5, 6, 7 and 8. So now the index is 2, so we'll make a group of 2's. So 2, then another pair, another pair, another pair and another pair. So this comes out of the radical as a single 3. Then this first pair is a single r outside. The second pair is another single r outside. This pair is another single r and another r. And inside we're left with only 3 because the rest of all the numbers and variables have come out. So now we'll solve outside the radical. Multiply 9 times 3 is 27. R, we have got 4 r's, so that means r to the power of 4 square root of 3. Inside nothing else can be done because we just have number 3 inside the radical. So 27 r to the power 4 times square root of 3 is the final answer, can be seen in option C. The next question says simplify, and we given 2 sm to the power of 4 a squared. Now the index is 4. Inside the radical we have 16 s to the power of 9, k to the power of 4, m to the power of 8 and a to the power of 3. Now let's write down the expression outside the radical. Index 4. 16 can be written as 2 times 2 times 2 times 2. 4 2's make up a 16. Now s will come 9 times. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. K will come 4 times. 1, 2, 3 and 4. M will come 8 times. 1, 2, 3, 4, 5, 6, 7, 8. and a will come 3 times, 1, 2 and 3. All this is inside the radical. So now we'll be making a group of 4 because the index is 4. 4 twos, 2 groups of 4s, then 1 k, like this. A are only 3, so we leave them as it is. Now we can pull out 1, 2 from 2 pairs of groups of s. We have got 2 s's, then 1 k, 2 m's. Inside the radical we are left with 1 s, that is this one, and a cubed because nothing can be done to the a, not to forget the index 4. Now we'll combine outside the radicals the numbers first. 2 times 2 is a 4, s is 1, 2, 3, so s cubed. M we have 4, 5 and 6, m to the power of 6. Then we have k, sorry, first let's take the a square as it is, and then k. I think we've done all, and inside we are left with sa cubed with the red index 4. This is our final answer. Let's see which option it is matching to. Sa cubed inside, that is I think option B, 4s cube, m6, ka square. Correct. B is the correct option. Moving on to the next question. Simplify, and we're given 6y4 z cubed radical 3w cubed y cubed g cubed m8 z cubed. So now we can write this down as 6y4 z cubed. Inside the radical 3 times w 3 times 1, 2, 3, then y 3 times 1, 2, 3, then we have g 3 times 1, 2 and 3, then we have m8 times 1, 2, 3, 4, 5, 6, 7 and 8, and then z 3 times 1, 2, 3. All this is inside the radical. So then we start making groups. Here the index is 2, so we make pairs of 2s. So 2 y's, 2 w's, 2 g's. M we can make 1, 2, 3 and 4 pairs, and then z. Sorry, this is z over here. So we have, start pulling out 6y4 z cubed, 2 w's to make 1 w, 1 y, 1 g, then we have 1, 2, 3, 4 m's, 1, 2, 3, 4 m's, and then 1 z. Inside we are left with 3 w, y, g and z. All the m's have come out. So now we combine outside the radical. 6 y4 and y1 is y5, z cubed and z to the power of 1 over here is z4. W will exist alone because there is no other w. Then we have g also as a single, and m we have 4 m's, so this combined to make m to the power of 4. Inside the radical we have 3 w, y, g and z. Let's see which option is matching. This is our final answer. 6, okay, 6 we have only in C and D, so option D is the correct answer. 6, let's arrange that as the answer. 6, then W, Y5, G, M4, z4 inside the radical 3w y g z. This is absolutely same to what we got. I hope simplifying radical expressions including variables which required some factoring is easy now. Thank you for watching and have a nice day.